Hello my friends, in this video we will be taking a look at the autosomal DNA results, predicted phenotype traits, and G25 results of a medieval, actually not even medieval, an early modern individual woman, a post-medieval woman from Suzdal from central Russia, a 18th century woman from Suzdal. The sample name is KED001. Her mitochondrial lineage is H. That's the lineage that was predicted with James Lick mitochondrial predictor. The second closest match is H24A. I'm not seeing H here on the illustrative DNA listed lineages, so I'm assuming her mitochondrial lineage is actually H24A because I do see H24A here. So I'm seeing first place H, but then I'm also seeing first place H24A. So her lineage might actually be H24A. So maybe her lineage is H24A in reality. So I'm not really sure how to interpret that. Why does it say first place both H and H24A? Maybe you guys in the comments can let me know how I should interpret this result, because she is scoring for the first place at the same time H and H24A and also H whatever this is. So her mitochondrial lineage, from what I understand, is H24A, because this is what I see on the page for illustrative DNA. But let's just assume it's H24A because this is what they have on illustrative DNA for these samples. So it's KED001, and this is what she scores with G25. This is her closest modern populations to G25. What's very interesting about the sample is these samples from Volga-Oka, from Suzdal in the late medieval period or after the medieval period in the 18th century, they're very, very different from samples in Suzdal in the early medieval period. So, for example, if we look at these samples in early medieval Suzdal, you see they're similar to Russian Pinezhsky, Krasnoborsky, and then there's even Karelian. Mordvin is not that extreme, but there's Finnish East, there's Ingrian, there's Finnish North. There's all these extreme northern groups that they score, such as Karelian and Finnish. Um, and then there's Russian post-medieval, which is closest to Russian Tver and Ryazan and Kursk and Oryol, which is like central Slavic central Russian. And there's even Ukrainian here, and Ukrainian from Dnipro and Ukrainian from Donetsk, which is Slavic people from Eastern Europe. And this individual from Volga-Oka is also very, very Slavic in her result. You can see it's closest to Oryol, Kaluga, Tver, Ryazan, Kursk. All of these are very Slavic groups. They don't really have much Uralic ancestry. They have a little bit of Uralic ancestry. Oryol has almost none. Kaluga has almost none. Tver has a little bit. Ryazan has a little bit. Kursk has almost none. So once again, all of these closest Russian groups to this individual have almost no Uralic admixture whatsoever. So it's very interesting that this individual from 18th century Suzdal has very, very little Uralic, almost no Uralic admixture whatsoever. It's a very Slavic sample. So it's one of the super Slavic samples from this region. Then Belarusian comes up, then Russian Smolensk. Smolensk is also very Slavic. Then we see Moksha, but Moksha is also very Slavic. Moksha is not Uralic whatsoever. Then we see Ukrainian Dnipro. Then we see Estonian, but Estonian is not really Uralic either. Then we see Finnish Southwest, Ukrainian from Sumy, Kazakh Ukrainian, various Ukrainians, Ingrians, Lithuanians, Russians, and whatever. Then that makes sense. Now for the ancient breakdown, as in with illustrative, I tried to do something like this for this sample, and this is what we get. For illustrative DNA, if this person, Volga-Oka individual, KED001, it's a female, by the way, it doesn't have a Y-DNA. Normally in my videos I include Y-DNA, but in this case, it is a female. And all the other samples from this post-medieval Russian Suzdal, all the other 3 samples, they are actually all female, so none of them have Y-DNA. So if I cover the other samples in my other videos that I make, you probably will not see Y-DNA for them either. Well, you won't see Y-DNA for them because they don't have Y-DNA. They're all female. But anyway, so this female, this woman, this Russian woman from Suzdal, she gets modeled as a mixture of mostly Slavic, but so if you add up the 34.2 plus 26.0, that's going to be That's gonna be what? That's gonna be, I think 20. No, that's gonna be 50. 50. No, not 50. That's gonna be 60.2% Slavic, and that's also gonna add up to 16.8% Baltic, and that's also gonna add up to um, I think 20. Man, difficult math. 23% Volga and Sarmatian. Actually, let's remove the aggregate because I want to see what exact samples um she's scoring. So she's scoring for the Slavic for the first part. She's scoring mostly post-Edenia Viking Age, which I'm not really sure what that is. For the second part, for the Slavic samples, she's scoring Krakauer Berg, which, okay, I guess that makes sense. For Baltic, she's scoring Swedish Gotland Viking Age, which I don't really know what that is either. For Volga-Oka Iron Age, she's scoring Большой Давыдовская 004. Interesting. Sarmatian, she's scoring Sarmatian's Caspian Steppe, alright. And for Slavic, the last Slavic, she's scoring Krakauer Berg once again. Alright. Interesting sample breakdown. Uh, alright, quite interesting. Okay, alright. So let's see what she scores with my own tools. Let's see what she scores for the Nasha code calculator results. For the eye color, hair color, what kind of phenotype she had. So it looks like the eye color she most likely had was green at 46.8%. Most likely she had green eyes. Dark brown eyes are very, very improbable for her at 0.01%. Very much improbable. Blue eyes are the second most likely eye color for her after green. Blue eyes with an amber center, third most likely eye color. And hazel eyes, kind of improbable, also very, very much improbable. Brown eyes definitely out of the picture. So she's quite light in terms of eye color, but most likely green. It's interesting that she's most likely has green eyes instead of blue. For hair color, likelihood distribution, most likely she has dark blonde or light brown hair. For light blonde or for dark brown hair, this is kind of unlikely, so she most likely falls into the light blonde to dark brown hair spectrum. For skin color likelihood distribution, she most likely has white or palest skin. So, like olive or light brown or dark brown skin, this is kind of unlikely for her. For hair texture, she most likely has wavy or straight or curly hair. Kinky hair is not really possible. For nose shape, she most likely has a Greek nose shape, so that's very interesting. Um, well, there's also a pretty big possibility of snub nose shape as well. It's 30%. 30% is significant, but it is interesting that she's scoring very high for Greek nose shape. Looks like she's got all the light color variants and variations of HERC2. She's got heterozygous genotype for blue haplotype 3. She's got BEH2 and BEH1. All right. She's got two light color variants here, so in SLC45A2, so probably has light pigmentation of eyes, hair, and skin as well. No genotype for this variation of SLC24A5, but we can assume she has two light color variants here as well. Okay, no light color variants anywhere in these variations of MC1R, so we can assume she doesn't have any predisposition to being ginger. Alright, now let's see what she scores for the phenotype oracle. Let's see what phenotypes she resembles most. So it looks like the phenotypes most close to her are, well, this, which is corded, which is like a typical phenotype for Russians, and it makes sense considering her ancestry. She's very Slavic, and Slavic people look like this very frequently. The second closest phenotype is this version of corded, but with green eyes, and the third closest phenotype is Nordic, Northern European. And the phenotype oracle, the closest mixture is a mixture of corded phenotype with green eyes plus Nordic. The second closest mixture is a mixture of corded phenotype. What's the difference? No, I see the difference. The second closest mixture is a mixture of corded phenotype but with blue eyes plus Nordic. And the third closest mixture is a mixture of corded phenotype but with hazel eyes plus Nordic. Alright, I see the difference. And the fourth mixture is a mixture of corded phenotype with blue eyes plus corded phenotype with looks like blue eyes as well. And the last mixture is a mixture of balted phenotype plus looks like corded phenotype with green eyes. Let's see the ethnic calculator results. Actually, I haven't shown you that yet. So let's see that. Well, with the ethnic calculator, okay, this is way off. This is way off. She's closest to Belbeaker from Britain. Okay. This is done on the basis of 466 SNPs. So she's closest to Belbeaker from Britain, followed by Bulgarian, followed by French. These three closest populations are completely off. But corded where give a karai. This is okay. This is kind of good. This should be way closer. Followed by that is Spanish, which is not good. Followed by that is Belbeaker and British and North Italian and Global Around for and Jewish Ashkenazi. So it seems that my calculator made her way more like Western and Southern than reality, but it's okay. It's all right. It's not that bad. And the mixture is Islamic period Iberian plus North Italian. That's the closest mixture, which is kind of really bad because she's quite more northern and eastern in both of these groups. The second closest mixture is Erfurt Jew plus Bailulai Lithuania medieval. Once again, this Jewish component is very. She doesn't have this Jewish component. She's very Russian and Slavic. So once again, this was inaccurate. This ethnicity calculation was quite inaccurate. Islamic period Iberian plus North Germanic, once again quite inaccurate. This calculation is finding some um, southern or Mediterranean admixture in her, but she doesn't have this southern admixture. I see Bailula Lithuania medieval plus Afghan. Once again, she doesn't have this Afghan admixture. It should be looking like Bailula Lithuanian plus Slavic or Bailula Lithuania plus um, Kievan Rus instead of Afghan. You see Pinarbasi Hunter Gatherer plus Bailulai once again, so it should be Kievan Rus plus Bailulai instead of Pinarbasi Hunter Gatherer plus Bailulai. So once again, the Oracle is looking quite bad. It's not looking very good. So it made her a lot more southern than she is in reality. Um, but it's kind of okay, It's not that bad. It's all right. I think it's all right. It wasn't that horrible. Let's see what she scores for the biomarkers results. Biomarkers panel. Biomarkers panel, she's scoring above average for the levels of vitamin D, below average for the levels of LDL cholesterol, below average for the levels of HDL cholesterol. So below average for both LDL and HDL cholesterol. I'm not sure what to make of that. So below average for LDL is really good. Below average for HDL is kind of bad. She's got below average for glucose levels, which is good. She's got average for hemoglobin. She's got above average for blood pressure, which is bad. She's got average for level of iron in the blood. She might have variants for hemochromatosis, so we'll check for that later. She's got average for sex hormone binding globulin. She's got below average for red blood cell count in blood. She's got below average for base pairs for telomere length. All right, let's check that. And she's got above average for height. So she's got slight predisposition to be taller. Definitely very interesting. Let's see what she scores for the polygenic risk scores. So it looks like she's got a predisposition to average odds of kidney stones. Definitely very high odds for hemoglobin E disease, and she's got risk variants here. Below average odds for migraine, average odds for lupus. Very low score for gout. Wow, very interesting. This is one of the lowest scores for gout I've seen so far. Low score for thyroid cancer, very low score for eczema. Below average score for all the glaucomas that I look for. Um, Below average score for polycystic ovary syndrome, below average score for cataracts, very high score for age-related macular degeneration. Let's look that up. Because I know I have that in the file. So it looks like she's got this genotype for increased odds of AMD and this genotype for increased odds of AMD, but she also has this genotype which leads to higher odds of AMD. Definitely very interesting. All right. She's got average odds of rheumatoid arthritis. She's got below average odds of Tourette's. She's got slightly above average odds of epilepsy. She's got slightly above average odds of asthma. She's got below average odds of leukemia. She's got above average odds of vitiligo, below average odds of myopia, average odds of corneal astigmatism, average odds of primary biliary cirrhosis, below average odds of stroke, higher than average odds of male pattern hair loss, which is kind of typical for Europeans to score, so that's not surprising whatsoever. She's got below average odds of atrial fibrillation and no risk variance for atrial fibrillation in the file, which is definitely really good to see. No risk variance for deep vein thrombosis, really good to see. Above average score for depression, so she's got some predisposition to depression, and very low score for bipolar type 1, which is really good to see, and low score for schizophrenia, which is also really good to see, and low score for type 2 diabetes, but high score for type 1 diabetes. Actually, let's check asthma. What does she score for asthma? She's scoring above average for asthma, so she might have risk variance for the HLA panel. Hold on. We're gonna check the HLA panel in a little bit. She's got below average odds for Alzheimer's, and she's got below average odds for multiple sclerosis. Definitely very interesting. All right, so for the breast cancer, she's got 3 risk variants. None of them are labeled as important, which is good. For testicular cancer, 8 risk variants out of 16, and she's got 2 risk variants in both the important variants and KED001, so she's definitely quite cooked for testicular cancer, but it's good for her because she doesn't have testicles. She's a female. No risk variants for celiac disease, no risk variants for GSS. Crohn's disease, 5 risk variants, but none of them are labeled as important. No risk variants for Greifenstein's, no risk variants for Parkinson's, no risk variants for Gilbert syndrome. It looks like no risk variants anywhere except for Brugada, but this is common. No uncommon risk variants anywhere. And for allergies, she's got 8 risk variants out of 18 total, which is kind of typical, and they're all common. All the risk variants for allergies are common here, so that's kind of good. That's really good to see. Nothing unusual in this file. The score for type 1 diabetes is kind of high, and this is the highest thing she scores. Age-related macular degeneration score is really high as well. So the thing that she scores really high for is age-related macular degeneration and type 1 diabetes. So I guess this is what we have to walk over, as well as the rare diseases panel, and we'll be done there. So let's try to look over the file. So it looks like for mental health results section, she has a predisposition to Warrior phenotype, slower dopamine reuptake, and higher dopamine levels. So Warrior phenotype takes into account the COMT, MAOA, and MAOB gene panels. So you have less of the COMT and MAOA enzymes that break down dopamine. Therefore, you have higher dopamine levels and more ability to concentrate and work on tasks, accomplish tasks. However, in high stress environments, when you have naturally higher dopamine production, you have too much dopamine, so you end up having lower productivity. So in high stress environments, you perform poorer. She has this kind of a phenotype, warrior phenotype. For DRD2, she has a predisposition to less dopamine D2 receptor sites. Definitely very interesting. That's typical for Europeans. Very common for Europeans to score less for that. And she actually has A1 allele and TOC1, which greatly reduces the number of dopamine D2 receptor sites in the brain. Doesn't have any alleles for dwarfism. And for 5-HT3-LPR, she's got short form 5-HT3-LPR, and she's got intermediate levels of 5-HT serotonin in the brain, which predisposes her to average odds of stuff like depression and anxiety, stuff like that. All right, for autism, looks like she's got intermediate odds of autism. So intermediate odds of pretty much it's in the name. For OXTR and empathy gene, looks like she's got average level of empathy, predisposition to average level of empathy. Based on these 5 S&Ps, she's got an average predisposition to empathy. For lactose persistence, based on these 4 S&Ps, it looks like she's got a predisposition to being lactose persistent. Yeah, which is really cool. So she's definitely lactose persistent. All right, and maybe I should make a panel for lactose persistence as well, like for empathy. Like this graphic would be pretty cool to make that. Maybe I will in the future. Diabetes. Let's see. She was scoring really high for type 1 diabetes, so let's find out why. She's got this genotype for increased risk of type 1 diabetes and rheumatoid arthritis. She's got a genotype for slight decrease in risk of type 1 diabetes. She's got a genotype for slight decrease in risk of type 1 diabetes, and she's got a genotype for lower risk of autoimmune disorders and type 1 diabetes. So overall, she's got quite good stuff here, but very interesting stuff. Very, very interesting stuff. No risk variants for Alzheimer's and APOE. All right. For multiple sclerosis, no risk variants for multiple sclerosis and HLA, which is really good to see. Okay. Um, Looks like she has a predisposition to lower odds of cardiovascular issues, which is really good stuff. So she's quite protected from cardiovascular conditions. No East Asian genotypes in EDAR, which is really good to see. So all three variations that my trade predictor tests for, she's got European genotypes for EDAR. Larger nose size, higher odds of protruding nasal bridge, thicker eyebrows, lower odds of missing teeth, and longer mid-face length. She does have risk variants for vitiligo in the HLA gene, so I'm really curious to see what her HLA panel looks like. There might be some fishy things going on there. No micropenis, really good to see. Really good to see that. Better performing muscles, likely sprinter rather than endurance athlete. One fat gene variant, NFTOs, RS9959609, high odds of obesity and sleep apnea. And it looks like she's not an Asian flusher, and she's got lower odds of alcoholism and normal risk of esophageal cancer. All right. No risk variance for pain hypersensitivity out of 6 total, which is really good to see. Slightly above average odds for alcoholism based on this alcoholism panel. No risk variance for familiar Mediterranean fever. No risk variance for albinism. And also, she does have some variants for impaired folate metabolism in MTHFR. So based on this, I feel like she might score some bad stuff for the homocysteine panel on the bottom. For the homocysteine, she might score elevated levels of that, just based on these genotypes in MTHFR. Okay. All right, rare diseases. We wanted to get to that, so let's see for the rare diseases. What does she score for that? We remember she was scoring high for the hemoglobin E disease, for AMD, and for type 1 diabetes. But let's see if she has any conditions for rare diseases, any predisposition to rare diseases. 5.2 times the risk of rheumatoid arthritis, and 2.1 times risk of aspirin-induced asthma, but possibly lower risk of intractable Graves' disease. I'm not really seeing. Oh wait, I'm seeing something else here. I'm seeing carrier of one pseudo sulfate A deficiency allele. So that's probably the most concerning thing here in the rare disease panel. Besides that, I'm not finding anything else here. So she's a carrier of this one pseudo sulfatase A deficiency allele, which is definitely very interesting. Let's look this up actually. What is this implicated in? Pseudo isosulfatase A deficiency possible. Um, ARSA is enzymatic activity, and when two copies are inherited, I'm not sure what does this. Okay, metachromatic leukodystrophy, MLD. Leukodystrophy is like when you have brain degeneration. So that's pretty badass. That's pretty bad. That's pretty bad. All right. Anything that has dystrophy in it is really bad. So you already know that's pretty bad to see in a report. For celiac disease, no risk variants in HLA-DRB1. No HLA-DQ8 haplotype, really good to see. So probably we're not going to see anything too bad on the HLA panel. We're probably not going to see anything too bad. No risk variants for APOB gene panel. She has this genotype in AR, which leads to a protection from baldness, which is very interesting. I remember that here the protective variant, which is I think A. Let's look this up. I think A is the protective variant here, but no, this is not what I wanted to see. I wanted to see SNPedia. Yeah, I think A is the protective variant here, but it's really uncommon for Europeans. Europeans tend to have GG. Europeans tend to have GG here, and it's sub-Saharan Africans who have A allele. So it's really surprising that she has the A allele here that protects from baldness. I'm not sure how she has this allele, but she does. For HIV and AIDS panel, looks like she has no protective variants here. So she's got HLA-B, this whatever carrier, most likely rare, and increases susceptibility to AIDS and psoriasis, which is definitely very interesting. Okay, and for HLA gene panel, looks like she has Actually, she has a predisposition to intermediate odds of autoimmune disease, which is definitely very, very, very bad. Because of that, she's scoring higher for the odds of type 1 diabetes. So this definitely contributes to her scoring high for the odds of type 1 diabetes. And this plays a role, like this and her score for the HLA variants for um, vitiligo. This plays a role, so it makes sense why she's scoring the way she is. So she's scoring higher for type 1 diabetes because of that. Also, asthma. There's a couple other conditions I think where HLA score affects that a little bit. So um, it makes sense why she's scoring the way she is. Now that you consider that, I'm really curious to see what she scores for the. Let's see. Nope, she's not scoring elevated, but she is scoring 3 times more for elevated than she is for lower. So once again, for homocysteine levels, she's still scoring intermediate homocysteine levels, but she is scoring 33% for elevated and only 11% for lower. So once again, my intuition to predict that she would score elevated was sort of right. Um, she is scoring much higher for the elevated than she is for lower. So there is a predisposition to elevated levels of homocysteine levels. But overall, she's still quite good. Overall, she's still quite doing all right. MTRR gene panel looks like she's got some risk variants for disorders of intracellular colloidal metabolism, like here and one here. But overall, she's doing pretty good. No risk variants overall. And for muscular dystrophy myopathies, no risk variants here. No risk variants for ADL. Color blindness panel, no risk variants in any of the 3 genes. Oh, look at that! It found variations in all 3 genes, which is really rare. I don't see that very often, so that's pretty good to see. For fat gene variants in FTO, looks like she's got homozygous for fat gene variants in these. Wow, she's got homozygous for all of them except this one. So she's actually really predisposed to obesity, at least in the FTO genotype. So definitely has some predisposition to obesity. Definitely really cool to see that. She's got this genotype for lower BMI. She's got this genotype for lower odds of obesity. But overall, she's definitely really predisposed to obesity. Syncope panel based on 4 S&Ps, she's got below averages of syncope, really low score for syncope. For biotraits panel, um, let's see, what can I talk about here? She's got 2 copies of the hunter-gatherer CLT-CL1 gene variant, which leads to reduced ability to process carbs and sugars. Definitely very interesting. She's more able to detect beta-iodine floral fragrance, which is definitely really cool to see. For vitamins and levels, she's got some genotypes for intermediate odds of KOPD if you smoke, lower levels of average levels of vitamin D. She's got a genotype for lower levels of vitamin D. She's also got a genotype for normal or higher levels of vitamin D. She's got a genotype for intermediate levels of vitamin D. She's got also a genotype for higher levels of vitamin D or decreased odds of vitamin D insufficiency, which is another way of saying higher levels of vitamin D. She's got genotypes for increased blood pressure. She's got a genotype for lower blood cell count. She's got genotype for lower level of vitamin K, lower level of vitamin E, lower level of vitamin A or retinol, and intermediate level of vitamin B6. And finally, for the blood group, looks like her blood type is most likely type O or type A. But type O is coming in at 56%, whereas type A is coming in at 42%. So most likely it is type O. But let's go through the results. Let's go through the S&Ps that contributed to this result and see what we can find out here. So she's got a result for most likely type O or A, which makes sense. She's got a genotype for higher odds of all blood types besides A, makes sense. Possibly blood type O or A, once again, makes sense. Most likely blood type B or AB. So this makes me think possibly blood type A, because there is some overlap between the S&Ps that contribute for score for blood type B or AB and blood type A. No blood type B or AB, alright. Likely not blood type AB, alright. Likely not blood type AB. Likely blood type O, alright. Slightly lower odds of B and O blood type. So it's kind of difficult to say. It's kind of difficult to say whether it's blood type O or A. So I understand why the prediction is split between O and A. But blood type O is a little bit more common. So I think statistics wise, um, it would be probably a little bit correct to assume that her blood type is O and not A. She most likely has blood type O. And I guess this is what the result is showing, right? So 56% is higher than 42. So she most likely indeed has blood type O. Thanks for watching until the very end of the video. I want to remind you that you can download the raw DNA file that I analyzed in this video from link which is in the description of the video. Also in the description of the video will be a link to the download and buy page for my trade predictor. You can buy the executable which allows you to generate these reports for any raw DNA file in microarray sequence format. So MyHeritage, 23andMe, or Ancestry DNA file format, you can generate a report like this, like what you've seen in this video, and the executable will cost you $25 currently. I might do a sale sometime in the future, but currently it costs $25. And the link to that um, site will be in the description of the video. Also, you can, if you don't have the $25 or if you don't have a Windows or a Linux system, you can purchase a report for $4 for one file or for $7 for two files. And the link to purchase these reports and to upload your files to me will be in the description of the video as well. So make sure you read the description. And thanks for watching. Leave a like and subscribe if you enjoy the content. Goodbye.